Okay, so we are going to discuss power of sines and cosines. This is for integral calculus. So for sine u raised to m and cosine u raised to n, if m or n is an odd positive number, factor sine u or cosine u and use sine squared u is equal to 1 minus cosine squared u, or else factor cosine squared u equal to 1 minus sine squared u. If m and or n is an even number, use the identities cosine squared u is equal to 1/2 1 plus cosine 2u, or sine squared u equal to 1/2 1 minus cosine 2u. Okay, the first example we have the integral of sine to the fifth 2 minus x dx. So if you are going to look at here, the exponent of your given, that is 2 and add exponent. If you will have an add exponent, you are going to factor out sine x and use sine squared x equal to 1 minus cosine squared x. So for our given, that is sine to the fifth, okay, sine to the fifth u or sine to the fifth x, that is equivalent to sine to the fourth x sine x. Then you use sine squared x, so therefore you will have sine squared x squared, that is equivalent sine to the fourth sine x. Wherein sine squared x, that is equivalent to 1 minus cosine squared x squared sine x. So this one, so that's the reason our second line, that is similar to this one. Second line, 1 minus cosine squared 2 minus x squared. Then you will have sine u. So you will have sine 2 minus x dx. Then after that one, expand 1 minus cosine squared u. That's the reason we have 1 minus 2 cosine squared 2 minus x plus cosine to the fourth 2 minus x. Sine 2 minus x dx. Then after that one, multiply sine 2 minus x inside. So that's the reason you will have 1 times sine 2 minus x dx. You will have sine 2 minus x dx. Our u here, because you have one trigonometric function, only one. It's only sine. So for that case, if you will have only one trigonometric function, your u is 2 minus x. U is equal to 2 minus x. Derivative of 2 is 0. Derivative of negative x, that is negative dx. So you multiply, your du is negative dx, but then your dx here is positive, so you add negative, multiply negative outside. So that's the reason you will have negative here. Plus, okay, so this one, if we are going to multiply sine 2 minus x inside, you will have cosine squared sine 2 minus x, right? So you will have, that is the same, so we just factored out this one. So you will have negative 2 cosine squared 2 minus x plus cosine to the 4 2 minus x. So times, okay. So if you are going to look at here, our u, okay, I have a sample here outside. Negative 2 cosine squared 2 minus x multiply sine 2 minus x dx. Okay. So our n here, our n, that is 2. You will use u to the n here. Why? Because you have two trigonometric functions. If we have two trigonometric functions, that is u to the n. If we have one trigonometric function, your u is your 2 minus x. So if you have two trigonometric functions, that is cosine and sine, one of that is for du. So n here, your exponent, n is 2, u is equal to cosine 2 minus x. U is equal to cosine 2 minus x. Derivative of cosine, negative sine 2 minus x. derivative of 0, derivative of negative x, that is negative dx. So if you are going to look at this one, that's the reason we have here for our du. This is our du. So our du is negative sine 2 minus x, negative dx. So negative, negative, that would become positive. So you don't need to multiply negative here. So that's the reason you have now a complete u to the n, du. So this one, okay, this one, this is your u to the n. This one is our du. So our du is this one now. So you have now complete u to the n, then du. So you proceed to u to n plus 1 over n plus 1. So that's the reason you will have 2 cosine 2 plus 1, that is 3. So 2 cosine cube 2 minus x over 3 plus cosine to the 4th plus 1, so 5th. So cosine to the 5th over 5, 2 minus x plus c. So that is now the final answer. Okay, let's proceed to the next example. That is number 2. The integral of sine to the 4th 4 theta cosine cube 4 theta d theta. So the integral, if you are going to look at here, one of your exponent is odd number. So we have here, that is 3. So what we're going to do, factor out cosine. So we factor out 1 cosine. So what is left is cosine squared. Then transform cosine squared to 1 minus sine squared. So that's the reason you have 1 minus sine squared 4 theta. Then you will have cosine 4 theta d theta. Okay. After that one, multiply cosine to the 4th theta inside. So do with sine to the 4th theta inside. So that would become sine to the 4th theta, sine to the 4th 4 theta times 1. So sine to the 4th 4 theta times cosine 4 theta. So cosine 4 theta d theta minus the integral of sine to the 4th times sine squared. So sine to the 6th 4 theta times cosine 4 theta d theta. If you are going to look at here, we have two trigonometric functions. If we have two trigonometric functions, we will be using u to the n. So, if you have two trigonometric functions, you use u to the n du. Then, answer for that, u n plus 1 over n plus 1 plus c. So, for this case, our u is equal to sine to the 4 theta. Our n here, n is equal to 4. N here, that is equal to 6. So if you are going to look at here, n is equal to 4, that is your exponent. Then u is equal to sine 4 theta, derivative of sine, that is cosine 4 theta, derivative of 4 theta, that is 4 d theta. So this is now your du. So because your du is a form of 4 cosine 4 theta d theta, what you have is cosine 4 theta d theta. That is lacking of 4. So 4 is being multiplied to your du. So that's the reason you are going to divide outside with 1/4. So do it here. Our n is 6. Then u is equal to sine 4 theta. Du, that is derivative of sine, that is cosine 4 theta, derivative of 4 theta, that is 4. So 4 cosine 4 theta d theta. What we have here, if you are going to look at here, what we have is only cosine 4 theta d theta. That is lacking of 4. So du, we multiplied with 4. Then we are going to multiply outside with 1/4. This is now a form of u to the n, complete form of u to the n du. So once you will have a form of u to the n du, u to the n du, proceed to u to the n plus 1 over n plus 1. So that's the reason we have n plus 1, that is 4 plus 1, that is 5 over 5. times 4, that is 20. So that's the reason you have 1 over 20 sine to the 5th 4 theta. Minus, this is 6 plus 1, that is 7. So that's the reason you will have sine 7 4 theta. 1 over 4 times 7, that is 28. So you will have 1 over 20 sine to the 5th 4 theta minus 1 over 28 sine to the 7 4 theta plus C as your final answer. Okay, the next example, we have number 3, the integral of sine to the 6 y over 2 dy. Okay, for the ruling for an even exponent, so what we're going to do if we will have an even exponent. So it states that if m or n is an even integer, use identities. If that is cosine squared, you will have 1/2 plus 1 plus cosine 2u. For this example, we have, so for even identities, you use cosine squared u, that is equal to 1 over 2, 1 plus cosine 2u. Okay. Or if you will have sine squared u, that is 1/2, 1 minus cosine 2u. Okay. So we have, in our given here, this is to the 6. If that is to the 6, what will happen? That is an even exponent. So you use this one, squared. So that you can use squared, you will have sine to the 6. Okay, sine to the 6u. That would be equal to sine squared u. So that you will have 6 multiply 3 inside. Okay. So that's the reason you will have squared, then you will have 3. So sine squared y over 2 to the cube dy. 2 times 3, that is still 6. So if we are going to multiply, okay, multiply this by cube, you will have sine squared y over 2, transform that first to sine squared u, that is equal to 1/2, 1 minus 2, 1 minus cosine 2u. In our given, that is sine squared. So in our given, we have sine squared y over 2. So that will be transformed into 1/2, 1 minus cosine. Okay. 2 times u. What is our u? Y over 2. 2 times y, that is 2y. Divided by 2, so the u will have y only. Okay. That's the reason our transformation, that is equal to 1 minus cosine y, okay, 1/2 outside to the cube. Then if you are going to expand 1 minus cosine y cube, okay, 1/2 raised cube, that is 1 over 8. 1 minus cosine y cube, you will have 1 minus 3 cosine y plus 3 cosine squared y minus cosine cube y dy. Okay. So we will have 1/8 integral of dy minus 3 over 8 cosine dy, okay, cosine y, okay, cosine y dy plus 3 over 8 multiplied by 1/8, 3 over 8 times, okay. If you are going to look at this one, this is cosine squared. The integral of cosine squared, that is equivalent to 1/2, 1 plus cosine 2u. So if you are going to look at here, your u is y. So you will have 1/2, okay, 1/2, 1 plus cosine, because this is y, then that is 2u, so 2y. You will have cosine 2y dy. Okay. So minus, okay, 1 over 8. 1 over 8 times, okay. This one is cosine cube. Cosine cube, that is an odd exponent. So transform that one, factor out cosine, then proceed to cosine squared. Cosine squared, that is equivalent to 1 minus sine squared y. Okay. Then after that one, the integral of 1/8, that is 1/8y. Then here, the integral of 1, that is y. So you will have 3/16. Okay, if you are going to look at this one, this is 1. 3/16 plus 1/8. Okay. 3/16 plus 1/8. So if you are going to look at this one, LCD is 16 divided by 16, that is 1 times 3, that is 3, plus 16 divided by 8, that is 2, plus 1 times 1, that is 2. So you will have 5/16. Okay, 5/16. So that's the reason you have here 5/16. And then the integral of cosine y dy, that is sine y. Then you will have the integral of cosine y dy, that is sine y. Okay. This is, so you have negative 3/8 integral of cosine y, that is sine y. So sine y. Then here you will have minus 1/8 sine y. Okay. So that's the reason you will have negative 3/8 minus 1/8. You will have negative 4. Negative 4/8. Which is equivalent to negative 1/2 sine y. Okay. So that's the reason you will have, that is equivalent to negative 1/2 sine y. So this one. So next, that is sine 2y. Okay, this one. The integral of, okay, this one. The integral of cosine 2y. Okay, 2y. Cosine 2y, the integral for that, that is sine, okay, the integral for that, that is sine 2y. Then we will have 1/2. Okay. So I will show you the solution. You will have the integral of cosine 2y, that is equivalent to 1/2 sine 2y. Okay. 1/2 sine 2y. So your answer here is 1/2 sine 2y times, okay, you have 3/16 outside, times 1/2. That's the reason you will have 3/32 sine 2y. Okay, that's the answer. Here, okay, this one. If we are going to multiply sine squared y with cosine y dy, that is 2 trigonometric function. You have 2 trigonometric function. So, u to the n, you will use u to the n. So, here, that is, you will have sine squared y, cosine y dy. Okay, this one. So, you will have, u here is sine y. du is equal to cosine y dy. Okay. So that is now a complete form. U to the n. So therefore, that's the reason you will have n plus 1. So sine cube over 3. So sine cube over y. It's negative, negative, so positive, plus 1/8 times 3, so 24. So that's the reason you will have sine cube y over 24 plus c. Okay, the next example class, that is number 4, the integral of sine squared 3t cosine to the 4 3t dt. So we will have This is sine squared. So, we will be using, okay, sine squared u, that is equal to 1/2 1 minus cosine 2u. Okay. If you will have cosine squared u, that is equal to 1/2. Okay. You will have 1 plus cosine 2u. Okay. So, therefore, we will have sine squared 3t. So, that is 1/2 1 minus cosine 2u. U is 3t, so that's the reason you will have 6t. So, 1/2 1 minus cosine 6t. This is squared to the fourth, so squared. So, squared, that is 1/2 1 plus cosine 2u. So, 1 plus cosine 6t, then squared dt. When you are going to square 1 plus cosine 6t, so if we are going to expand this one, then multiply here with 1 minus cosine 60. So that would be equal to 1 plus cosine 60 minus cosine squared 60 minus cosine cubed 60 dt. Then after that one, integrate. So 1/8, the integral of dt plus 1/8 times 1/8, the integral of cosine 60. Our u here, okay, our u, because one trigonometric function only, so our u is 60. So, u is 60. du is equal to 6 dt. So, this is our du. So, therefore, we multiplied 6 here, multiplied 1 over 6 outside. And then, you will have here cosine squared. So, cosine squared, you will be using 1 plus cosine 12t, the integral. So, we have here 1 over 8. Okay? 1 over 8. Then, we have 1/2 because from cosine squared, that is 1/2. So, that's the reason you multiplied here 1/2. Then, minus 1 over 8. Okay? Here, this is cosine cube. So, cosine cube, factored out cosine outside, this one. Then, transform cosine squared, 1 minus sine squared, 60. Okay. Then, our du here, that is equal to, okay, our du, if we multiply cosine inside, so, our u is 60. So, you will have this one. Multiply cosine 60, then 6 dt. So, we will have, okay, we will have 1 over 8, the integral of dt plus 1 over 8. Then, you will have your u is 60, so du is 6 dt. So, you will have multiply 1 over 6 outside. Here we have, this is a form of even exponent. So, proceed to 1 plus cosine 2u over 2. So, that's the reason you will have 1/8 times 1/2, 1 plus cosine 12t. Because u is 60. Minus, okay, you have 1/8. That is cosine cube. Cosine cube, that is odd integer. So, proceed to factor out cosine, then proceed to 1 minus sine squared. So, 1 minus sine squared, 60. Then, you have cosine 60 times 6 dt outside. Because your u here, if you will have the integral of cosine u, that is 6t. Then, derivative of 60, that is 6 dt. So, that is your du is 6 dt. So, that's a complete form. You will have the integral of cosine 60 dt. So, u here is 60. Then, du is 6 dt. So, that is now a complete form. So, complete form here, that is the integral of cosine 60, then 6 dt. Okay, that is your du. Then you will have here an answer of sine 60 1 over 6. So that's the reason you have here this one. Then the integral of sine squared 60, that is two functions, sine squared and cosine 6. So two trigonometric function, that is u to the n. So therefore you will have the integral of 1/8 dt, so 1 over 8t. This the integral of cosine 60, that is complete form, 1 over 48 sine 60. Then the integral of 1 over 16, so negative 1 over 16t minus, the integral of cosine 12t, our u here, that is 12t, du, that is 12 dt. So multiply 1 over 12 here. That's the reason you will have 1 over 16, 1 over 12 sine 12t. Minus the integral, the integral of cosine 60, multiply here. So that is, I've shown here, u is 60, du is 6 dt. So that is a form of cosine 60 times du. So you multiplied 6 to your du. So therefore multiplied 1 over 6 outside. So that's the reason 1 over 48 sine 60 minus two functions, two trigonometric functions, u to the n. So our u here is sine 60, du is cosine 66 dt. That is your du. So that is a complete form. So u to the n sine cube over 3. So 1 over 48 times 1 over 3. So that's the reason in our final answer, if you are going to combine everything, you will have 1 over 16t minus 1 over 9, 192 sine 12t minus 1 over 44 sine cube 60 plus c. Okay, the next example, that is the integral of sine to the fifth 2w dw over cosine 2/3 2w. So what we're going here, that is, this is odd integer. So therefore you are going to transform that one into sine squared 2w raised to squared, so that you will have 4. Then bring outside sine 2w dw. Then you transform sine squared 2w is equal to 1 minus cosine squared 2w. Okay, so that's the reason you will have, when you are going to, then you will have sine squared 2w, that is squared. So that's the reason you will have cosine squared 2w squared, and which is equal to 1 minus 2 cosine 2w plus cosine 2/4 2w. So this one, this is now the result. So you bring up cosine 2/3 up, because that is positive, that would become negative. Then multiply inside, so multiply cosine negative 2/3 2w inside. So you will have this one, you will have negative 1/2. So you will have here cosine negative 2/3 2w minus 2 cosine 4/3, that is 1 minus 2/3. So you will have raised to 4/3 2w plus cosine 4 minus 2/3, that is 10 over 3 2w. So you have two trigonometric function, cosine and sine. So you will use u to the n. So u is equal to cosine, du is your derivative of, U is equal to cosine 2W. Du is equal to negative sine 2W. Derivative of 2W, that is negative 2. So you will have negative 2dW. Okay. So this is now your du. So that one, this is now your du. Okay. So this is your du. Since in our sign we multiplied, so what we don't have here is negative 2. So we multiplied negative 2. So that's the reason we are going to multiply it outside negative 1/2. So our du is negative 2 sine 2 dw. So remember, we multiplied negative 2, so multiplied negative 1/2. Then proceed now to integration, n plus 1. So negative 2 over 3 plus 1. Okay, that's the reason you will have a negative 3 over 2 cosine raised to 1/3 2w. 4 over 3 plus 1. So you will have 1 over 7 over 3. So you will have a result, a final answer of 3 over 7 cosine 7 over 3 2w minus 3 over 26 cosine 13 over 3 2w plus c. Okay, that is now your final answer.